Hello everybody, welcome to the tutorial, which is a memory card game built in pure JavaScript. So to follow this tutorial, you don't have to know a lot, just the basics of HTML, CSS, and JS, like basic tags, basic CSS selectors, and what's a function. You can find the files for each video at github.com/codesketch and a written tutorial and the game demo at marina-ferreira.github.io. So if you get lost along the way, please refer to those. Okay? Let's get started. We are going to start with the basic file structure. So in our terminal, let's make a directory called memory game. Let's change directory into that new directory. To create the files, we are going to touch index.html, styles.css, and scripts.js. We are also going to make a directory called mig for our images. So in the editor, let's open our index.html. And declare our file as an HTML5 document with doctype. In the root tag, let's specify the language as English. And inside the head tag, let's set our character encoding to UTF-8, set the title to memory game, and link the style sheet. And inside our body tag, we are going to add the script. In styles.css, we are going to add a reset to all items by setting padding to 0, margin to 0, and box sizing to border box. The box sizing property handles how padding and border will be added to an element. The default value for box sizing is content box, which means that any border or padding applied to the element will add to its total width and height. The other option is border box, which adds padding and border to the element without changing its dimensions. So it shrinks the available space for the content, keeping its original size. One thing to keep in mind, box sizing does not apply to margin, okay? Either option you choose, margin will never be accounted as element's dimensions. Let's set the body height to 100 VH. So VH stands for viewport height, and viewport is the visible area of your web page. So the unit VH corresponds to 1% of the viewport height. By setting it to 100, our body will take 100% of the available height space. And finally, let's set the background color. Our board will be composed of a container div called memory game and by 12 cards. Each card consists of a memory card div that holds two images, one representing the card's back face and the other representing its front face. So back in the editor, let's make that into HTML. To download the images, please visit the project repo at GitHub. So now that we have added all the elements, let's also add a temporary width of 100 pixels to all images so we can have a better idea of what's going on. In styles.css, we're going to be styling our memory game container and the memory card front face and back face elements. So let's add a border to each one of them so we can better visualize them. Let's remove that temporary image width and let's add a 640 pixel width and height to our container. Let's also set display to flex. So what's going on here is that when we apply display flex to a container, we kind of get some other properties set for us by default. So what those properties tell our items is each one of you will take the same amount of space in the screen. And to the container it says your items should be laid out in a row, and just one row. And they're going to be positioned from left to right, and they will be stretched out across the container's height. Our board has 3 rows, 4 cards each. So let's apply to the memory card a 25% width and a 33.33% height. Well, we can see that the height is being correctly applied, but the width is not. So remember when I said that we had some default properties in the flex container? One of them is flex wrap, which is set to no wrap and is preventing the items from being laid out across multiple rows. So let's reset it to wrap. Now we have to position the front face and the back face on top of each other. So let's add a position absolute to them. And well, this is not what we wanted at all. So let's take a closer look here. When you add position absolute to an element, the element has to find out relative to what am I going to position myself. It doesn't know, so it asks its parent, which in this case is box 3. So it goes, box 3, are you positioned? And an element is only positioned to the screen if it has a position relative set. Box 3 does not have that, so it answers, no, I'm not positioned. The element then goes, okay, not a problem, I'm gonna ask your parent. Box 2, are you positioned? Box 2 is gonna go, no, I'm not positioned. Okay, I'll ask your parent. Box 1, are you positioned? Box 1 is gonna go, no, I'm not. Then the element says, since none of you is positioned, I'm gonna position myself relative to the body. And this is why right now the element is sitting at the top left corner. If we apply position relative to box 1, when the element asks, box 1, are you positioned? Box 1 is going to go, yes, I am positioned. The element says, cool, then I'm going to position myself relative to you. And the same goes if we apply position relative to box 2 and 3. Which means that an element with position absolute positions itself relative to the nearest positioned ancestor. Back in our template, what's going on here is that since none of our elements are positioned to the screen, front face and back face are positioning themselves relative to the body, and we want them to be positioned relative to the memory card. So let's add a position relative to it. Let's make the images take the whole width and height of its container. And let's also apply some padding, border radius, and background color. Let's remove the borders and apply a 5-pixel margin to our memory card. The layout has broken because the margin makes our cards overflow the available space. Okay, so on calculating our width and height, we have to take that margin under consideration. The CSS calc function allows us to subtract the margin value from the width and height. So let's apply that. For centering the memory game container, we're going to apply a display flex to the body and margin auto to the memory game, and that's going to center it vertically and horizontally. Let's add a click effect to the memory card. So the active pseudoclass is going to be triggered whenever an element gets clicked. So we're going to apply a transform scale of 97% of its original size. Let's make that a bit smoother by applying a transition to it. And for that transition to work, we have to have a starting place. So let's apply transform scale 1 to the memory card. There's a typo here. And there you go. So now let's make the card flip when we click it. The first thing we have to do is to make a list of all memory card elements and store it inside a constant named cards. To do that, we are going to use document.carrySelectorAll, passing the memory card class. So then we are going to loop through that list, and to each one of the cards we are going to attach an event listener. We are going to listen for a click event, and whenever that event is fired, we are going to execute a function named flipCard. Let's declare the flipCard function. And let's log a message to see if it's working. And let's also see what's inside the this keyword. Okay, because this value is dynamically set according to the context. So let's see in this context what our this keyword represents. So you can see our function is being called. And inside the this variable, we can see that we have our memory card. So in this context, the this keyword represents the element that fired the event. Okay? So what we want here is to access the class list of the memory card and to toggle the flip class. What toggle means is if the class is there, remove it. If it's not, add it. Okay, so let's navigate to our Elements tab. And we can see that it's toggling the class. So back in styles.css, let's add that flip class. So we want to select the memory card element that also has a flip class. Remember that there's no space between the names because the two classes belong to the same element. Okay? So when the flip class is present, we are going to rotate the y-axis 180 degrees. Let's add a 3D effect to the card flipping. So the perspective property is what's going to give some depth to our elements, okay? So we're going to add a 1000 pixel perspective to the memory game container, and also a property that's called transform style preserve 3D to the memory card, because that's what's going to insert our memory card element inside the 3D space we just created in the memory game container. Because otherwise, the memory card is going to keep being flat, sitting on the 2D plane. So back in the editor, let's add those properties. 1000 pixel perspective to memory game, and transform style preserve 3D to the memory card. We still don't see the 3D effect because we have to add a transition to the transform property. And there we have it, the 3D effect. Well, when we flip the card, we should be seeing the front face, right? And right now what we are seeing is the inverted JS badge. That happens because every HTML element has a back face, which is a mirrored image of itself. Okay, there's also a property called backface visibility that defaults to visible, and this is why we are seeing the inverted badge. So the first thing you have to do is to hide the backface. And now that's hidden, we have to rotate the front face 180 degrees in the y-axis so we can see it. So when the player clicks a card, we have to know if it's the first or the second card that he clicks, so we can perform the matching logic, okay? So let's declare a variable called hasFlippedCard and set it to false, and also declare a first card and second card variables. Let's update here toggle to add, and we are gonna add a condition, okay? So if hasFlippedCard is false, this means this is the first time the player has clicked a card. So then we are gonna set hasFlippedCard to true, and we are gonna set the first card to the this keyword. Remember the this, the element that has fired the event? So in this case is our memory card. So let's console log both variables. So we can see we have the card we clicked, and hasFlippedCard is now true. And when we click again on other cards, it does not enter the condition because hasFlippedCard is now true. So if hasFlippedCard is set to false, it means the player is clicking at the first card. If it is set to true, it means the player is clicking in the second card. And it's gonna fall inside the else clause. So we are gonna set has flipped card back to false, and we are gonna set the second card variable to this. And let's console log those. Okay, so it fires only at the second click, and we can see we have the both cards we just clicked. So now that we have both cards we just clicked, we have to check if those cards match. And how are we going to do that? So we are going to make use of a very handy attribute in HTML, which is the data attribute. With that, you can add to your elements any kind of information you want. Okay? You can call it also whatever you want. You can call it data name, you can call it data image. We're going to call it data framework and pass the name of the framework the element is holding. So let's add that to every one of our memory cards. In order to access the data attribute that you defined in your HTML, we do this through the dataset object. Okay, so it goes your element.dataset. The name you have chosen. Now that we can identify our cards, we have to check if the dataset.framework from the first card and the second card are the same. If they are, we are going to remove the event listener from the cards to prevent them from being clicked again. And if it's not, we are going to then unflip the cards back to the original state. Okay? So let's add that condition. And if it's a match, we disable the event listener with remove event listener. So it works, you have to add the event and the function you called. To make sure they have been removed, let's add a log message here. Alright, they were correctly executed, and then when we click again, it won't fire because it's not going to the function anymore. And then if it's not a match, we'll unflip the cards. To do that, we're going to remove the flip class from the card. Okay, so the second card hasn't turned. So when we clicked the card, it has immediately removed the flip class, so we cannot even see it being flipped. What we have to do is to add a set timeout with a 1500-second delay, so there's enough time available for us to see the flipping. Right now, we have a bunch of nested conditions inside our code, and that makes our method very hard to read. So let's make some refactoring here. And first of all, we are going to extract the matching logic to its own method, and we are going to call it check for match. The code inside the if-else blocks are also going to be extracted to their own methods. In case it is a match, we're going to call disable cards, and in case it's not, we're going to call unflip cards. Now that we have just one statement being executed inside our if-else block, there's an even shorter way we can write this by using a ternary operator. So, a ternary operator has three blocks. The first one, we place our condition. The second one is the statement to be executed if the condition evaluates to true, and the third one if the condition evaluates to false. Alright? So, a ternary operator allows you to write an if-else block in just one line. And up here, we can switch the else clause for a return statement in the end of our if. Because if the condition evaluates to true, the return statement is gonna stop the function execution there. And in case it's not true, the code executed, it's the one that would be inside the else clause. So this makes the condition a bit cleaner. Right now, our game is a bit buggy because there are some corner cases we have to take care of. One of them is, if we try to flip a second set of cards before the first set have finished unflipping, then that crashes our logic. So, in case it's not a match, we have to lock the board and wait until the cards finish unflipping. So let's declare a lock board variable and set it to false. And the first statements are inside our flip card function will be to return from the function if lockboard is true. So the rest won't get executed. In case it's not a match, we're going to lock the board and only unlock it after cards have been flipped. The second corner case we have to pay attention to is if we click twice over the same card, because in that case, isMatch is going to evaluate to true and is going to disable the cards by removing its event listener. So the card is going to remain flipped. We have to add a condition to the beginning of our flip card function to avoid that. So if it is the first card click, then the this variable holds the first card, but the first card variable is still on set, so that condition is going to evaluate to false and the function will be executed normally. If it is the second card click, then the this variable holds the second card, and in case that equals first card, then it will return from the function. In order for a condition to work, after each round we have to set first card and second card to null. So let's extract that to a method of its own called resetBoard, and there we're gonna set hasFlippedCard and lockBoard to false and first and second card to null. And we can do this using the ES6 destructuring assignment, which keeps our code very, very short. The last thing left for us to do in our game is to shuffle our cards. We are gonna do this with a Flexbox property called order. That's a flex items property, and it defaults to 0, which means that every flex item belongs to the same group, and then they will be grouped by source order. If you assign a different integer to the order property, items will get ordered first by ascending order according to the value in the order property, and then they will get ordered by source order. So, to shuffle our deck of cards, we are going to generate a random number between 0 and 11 and assign to each one of our cards. Let's start iterating through our deck of cards. And to generate our random number, we are going to use the math.random function, which returns us a random number between 0 and 1, excluding 1. Since we want a number that goes from 0 to 11, we are going to multiply that number by 12. And since the order property needs an integer, we have to apply math.floor in order to get that. So now that we have our random number, we can apply it to the order property. We need our deck of cards to be shuffled before the player starts the game. So instead of calling the shuffle function as we normally would, let's wrap it inside a parenthesis and add an extra pair of parentheses to the end of it, and that makes that function into an immediately invoked function expression, which means that that function will be executed right after its definition. And that's it for our memory game tutorial. I hope you have enjoyed it. Please subscribe to the channel so you get our updates. Okay? See ya!